Alright everyone, grab your notebooks and let's dive into the fascinating world of physics. Today, we're going to explore the fundamental principles that govern the motion of objects. These principles were first formulated by Sir Isaac Newton, one of the most influential scientists in history. Today, I'm breaking down Newton's laws of motion in just 3 minutes, so buckle up. These laws are not just theoretical concepts, they have practical applications in our everyday lives. First up, Newton's first law of motion, also known as the law of inertia. This law is fundamental to understanding how objects behave when forces are applied to them. This law states that an object at rest stays at rest, and an object in motion stays in motion at a constant speed in a straight line, unless acted upon by an unbalanced force. It's why a book on a table doesn't move unless you push it. So, if you're sliding on ice, you'll keep sliding until friction or another force stops you. Pretty cool, right? This is why ice skating feels so smooth and effortless. Next, let's talk about Newton's second law of motion. This law is crucial for understanding how forces cause changes in the motion of objects. This one is all about force and acceleration. It explains how the amount of force applied to an object affects its acceleration. It tells us that the force acting on an object is equal to the mass of that object times its acceleration. This is often written as the equation F equals sine ma. In other words, F equals m times a. This equation helps us calculate how much force is needed to move an object. So, if you push a shopping cart, the harder you push, the faster it accelerates. This is why it's easier to push an empty cart than a full one. And the heavier the cart, the more force you need to push it. This is a practical demonstration of how mass and force are related. Finally, we've got Newton's third law of motion. This law is often summarized as action and reaction. This law is probably the easiest to remember. For every action, there's an equal and opposite reaction. It's a simple yet powerful concept. Imagine you're jumping off a boat. As you push down on the boat to jump, the boat pushes you up into the air. This is a perfect example of action and reaction forces at work. As you push down on the boat to jump, the boat pushes you up into the air. This interaction is what propels you into the water. That's Newton's third law in action. So, to recap, Newton's first law is all about inertia, objects resisting changes to their state of motion. Newton's first law is all about inertia, objects resisting changes to their state of motion. It's why a stationary object stays still unless a force moves it. The second law connects force, mass, and acceleration, showing us how they interact. It helps us understand how much force is needed to move objects of different masses. And the third law reminds us that forces always come in pairs, action and reaction. This principle is evident in many everyday activities, from walking to swimming. These laws are the foundation of classical mechanics and help us understand everything from how cars move to how planets orbit the sun. They are essential for engineers, scientists, and anyone interested in the physical world. Newton's insights have truly shaped our understanding of the physical world. His work laid the groundwork for many scientific advancements. I hope this quick rundown helps you grasp the basics of Newton's laws of motion. These principles are not just for scientists, they are for everyone who wants to understand how the world works. If you enjoyed this video, don't forget to hit the like button and subscribe for more awesome science content. Your support helps us create more educational videos. Thanks for watching and keep exploring the wonders of physics. There's so much more to discover and learn. Until next time, stay curious, keep questioning, keep exploring, and never stop learning.